Okay, welcome to Elevator World's webinar series. I'm T. Bruce McKinnon, and I'm the president of Elevator World and your host for today. Today's webinar is presented by Triumph Electrical Supply, as well as Argus Elevator. And today's topic is understanding door monitoring compliance. Today's speakers for the webinar are Steve Tomaszewski, Head of Business Strategy at Triumph Electrical Supply, and Omar Gill, the President of Argus Elevator. Argus is the manufacturer of the Argus Door Monitoring Unit, while Triumph is the exclusive distributor in New York City. In today's webinar, we'll learn how the Argus Door Monitoring Unit will help clients come into compliance as per the ASME 17.3 Section 310.12 Elevator Code. Argus has a proven track record of partnering with New York City elevator contractors to bring existing elevators up to this standard. With over 8,000 units sold and installed with 100 different types of controllers, Argus is the experienced leader in door monitoring compliance. During today's presentation, I'd like you to encourage to post your questions in either the question and answer section or in the chat box. And after today's presentation, we'll go through all those questions. So we'd like to go ahead and get started. Steve, Omar, you may begin the presentation.
Thanks, T. Bruce. I want to first off by thanking everyone for joining us today. We hope that you guys find this session informative. We're going to move through a lot of material. So as T. Bruce said, please, have your questions ready for us. First, to introduce myself, I'm Steve Tomaszewski with Triumph Electric out of New York City, and I'm joined by Omar Gill of Argus. To start this today, we're going to give you a brief introduction, then I'm going to let Omar take over and talk a bit about the code itself. Then we're going to detail if you want to order any of the Argus products, how to do such. And then we're going to wrap up with a Q&A session. So Triumph is the leading electrical elevator distributor in the New York City market. And our partner Argus has quickly cemented themselves as a thought leader and manufacturer of electrical components. The synergies of a partnership were pretty clear. Use Triumph's reach and relationships and help distribute the innovative Argus products. The results, I think, speak for themselves. In about 3 years, we have about 8,000 units sold, over 80 unique customers, and we're just beginning. There's still a lot of growth to come. So we invited you guys all here from throughout the US. We're going to be discussing door lock monitoring. As many of you know, New York was really the pioneer in this space. But that's been expanding really, really quickly. And at this point, I'm going to kick it over to Omar, the president of Argus, who's going to discuss more about the code. He's going to talk to you about your options to address it and how and why the Argus product has so quickly risen to become the leading solution in the New York City market. Omar, take it away.
All right. So thank you, Steve, and good morning, everybody. And thank you for joining in. So as Steve mentioned, we're going to be talking about the code. And I'm going to be keeping the technical level to, a low level, so just that we don't bore people that are not very technical. But I encourage everybody to pose any technical question you might have during the Q&A section. So I guess the first question is, what is door monitoring? So if you are outside of the New York City area, that's a question you might be asking yourself. As we all know, New York City was the first jurisdiction in the US that started requiring this code. And the rule is very precisely specifying the A17.3, specifically section 310.12. And it is basically a safety rule, some safety functionalities that are required from the elevator to give the elevators an extra layer of safety. So as we all know, elevators have two set of doors, the landing doors and the car doors. And each one of those set of doors have a safety device. In the case of the car doors, it's usually called the car door contact or gate switch. In the case of the landing doors, it's called the door latch. Now, those contacts are only supposed to be closed if the doors are closed in the case of the car doors and closed and locked in the case of the landing doors. If there is a malfunction with those contacts, there is a possibility that the elevator controller may not know that and it may take off with the doors not fully closed. So this code is to prevent that, to require the elevators to have that extra level of safety so that if those components fail, the elevator still will not be able to take off. And implementing door monitoring comes down basically to two different rules. They're independent and very clear, specified in the code. One of them is what we call car motion restriction, or CMR. And what that rule specifies is that the car should not move under certain conditions. The second rule, which is what we call door closing restriction, is about preventing the car doors from closing when some invalid conditions are present. There are some exceptions to those rules, but that's not something we're going to be talking about here. Like I said, we can talk about them in the Q&A section. Now, the next question is, what type of elevators are required to comply with this new rule? Now, if your jurisdiction recently adopted the code, then as the code says, it will apply to elevators that have power operated doors that are mechanically coupled with the landing doors. There are some elevators that have power operated car doors that are not mechanically coupled with the landing doors. So those elevators are not required to comply, but it might be a good practice to bring those elevators into compliance as well. Now, the next question will be, okay, how is compliance accomplished? So there are basically three different ways that an elevator can be brought into compliance. The first one would be as easy as activating a parameter on the elevator controller. That will only be possible if the elevator was recently installed and it already came with that functionality as part of the firmware package. So the mechanic will just have to go and go to the menu and activate that parameter. So the second option would be to get a firmware upgrade from the manufacturer. And for that to be a possibility, the elevator itself will have to be manufactured in a way that would allow a firmware upgrade to give that functionality. Also, that would imply that the manufacturer of the controller is still around and that they do have a software solution. Now, the third option, which is the one that we're going to be discussing here in more detail, it's by installing a device that provides that functionality. And that's where we come into play. So this is our unit. As you can see, this is the device that you will need to install to an elevator system to give these extra safety functionality. The first characteristic that stands out compared to our competitors is the small size of our unit. So in some situations, size does matter, and this is one of those. And the reason is that being so small, as you can see, it allows it to be installed right inside the elevator controller. That eliminates the need to have to install another box next to the elevator controller, having to run, conduit or greenfield or extra wires that consume a lot of time, and it doesn't look as an elegant solution. So it takes a lot of time. The second characteristic that stands out is the fact that it's very user-friendly. So as you can see on the screen, all the signals that need to get monitored and the outputs that the device have, you can see the status of all of that in one shot, basically in one single screen. So as the elevator is moving, opening and closing the doors, opening and closing the door locks and the gates, so you see in real time. Another benefit of the user interface that we have is that it can be used as a troubleshooting tool. 75% of the problems related with an elevator, the shutdowns, are related to the doors, either door locks, open and close limit, or door contacts. So the mechanic is able, once the unit is installed in service, not only you added that extra layer of safety, but it can be used as a troubleshooting tool because the mechanic can clearly see the status of all the signals. Another important aspect of the device is that it is future-proof. So if there was to be a change in the code in the future, let's say a year from now, the code changes and you need to add extra functionality or modify one of the functionalities, then the only thing that will be needed is a software upgrade to the unit, and we will need to send you a file, and we provide a serial cable, and with a laptop, you can upgrade the software of the unit. That is a scenario that actually happened in New York City when the code first came out, it didn't have any exceptions related to fire service. But then a year later or 2 years later, they adopted some modification to the original code, some exception that needed to be implemented in relation to the fire service. When that new modification came out, it made all the existing devices immediately non-compliant. So either a software upgrade or a modification to the device needed to happen. With those, that it's no problem, basically. Another very important aspect of a unit is the fact that it is extremely energy efficient. I mean, we know that, being energy efficient is it's a very good thing from a environmental perspective. But practically speaking, what that does to us is that it allows to specify the wiring of the unit, specifically the power source of the unit, from the same power source that is powering the control logic of the controller. So you don't have to worry about, getting new fuses or whatever to power the unit properly. You can power it right from the logic source. Now, like I mentioned, we do have a way to upgrade the firmware the unit if needed. Likely you're not going to be using that, but the functionality is there if needed. On the left side, you can see the screenshot of the application that we have for that purpose. And on the right side, we have an application that this is why you may actually use it. For example, if you have an elevator building that has 8 elevators and they are identical, they have the same controller, same configuration. So with this application, it allows you to save a file into the computer with the configuration on one of the units. Let's say you install one first and everything is working perfectly. So you can save the configuration of that unit into a file. You can have it for your records, but it also allows you to clone that unit and repeat the same configuration to the other 7 units, saving you a lot of time. Now, another question, what controllers have we installed our unit on? Well, this is a list of over 40 different brands of controllers that our unit have been installed successfully. The unit is universal, so it's going to work with any elevator system that was built and installed in the US, because by code, those elevators need to have the components and the signals that we need to monitor. But just to give a few examples of different controllers within the specific families of controllers. So within the Otis family, we have Gen 2, 411, 211, 401, even though it's not here, LRVs, LSRs, and a whole bunch of relay logic controllers. Within the Conner family, we have pretty much done everything related to the KCM A31 family, Montgomery's, Stanley's. Within the ThyssenKrupp family, we have done TAC 50, 32s, 20, Dover DMCs, Dover hydraulic, or better called, I think, or better known as composite, many relay logic. And within the MC family, we have done pretty much everything related to the iBots platform, the HMC family, the Tricom, IMC, Series 90, Microflight, that's from Al Thompson, and a lot of relay logic from the Al Thompson times. Now, you might wonder, okay, how is the unit installed, or what does it look like inside the elevator controller? So here you can see a few pictures. On the left side, on the top, you have a close-up to how the unit is wired and installed right inside the elevator controller. To the left side, we have the unit installed on a controller local to New York City, pretty much. It was called ACCT, if I remember correctly. On the bottom, we have the unit shown installed on a Dover DMC. In this case, it was installed right inside the cash station, because in this case, they didn't have enough spares. And on the right side, on the bottom, we have the sensor kit that we also provide that goes along with the unit for Dover DMCs like 50, 32s, and 20s. These are a few more pictures of how the unit gets installed inside the elevator controller. The first one on the top is Otis 411. The second one is an Otis relay logic. The one to the right side is an MCE. On the bottom, we have a Virginia Controls, a very old one based on the PLC. In the middle of the bottom, we have what I believe it is Al Thompson Microflight. And to the right side, we have an ESI controller. Here I have a video of showing in real time how the unit, what you would see when the unit is in operation. So let's take a look. So the elevator is going between floors, servicing different calls. So you're gonna see as the doors open and close, that's exactly what you're gonna see on the unit. So for example, right now, everything is closed. So the elevator is going between floors. Once it gets to our floor, you're gonna see how the door starts opening, and you can see it right there. You can see the door locks and the gate switch open. The unit is fully open now. Now it's gonna start to close, and it's gonna tell you that it's closing. And then when it gets to the closed position, it's gonna tell you close, and the elevator is gonna take off. We also have another video showing how the sensor kit that I just mentioned gets installed and how it operates. So it's very, very easy to install. You only have to remove one nut for this bearing, and then you put it back, and then you adjust the two magnets that we also provide with two magnet holders. And that way the unit can receive the open and close information of the doors. Now you might be wondering, okay, what kind of buildings have our units being installed on? And the answer is many of the most iconic buildings of New York City. So on the top, we have one example that is the 601 Lexington Avenue, or better known as the City Corp building. There we did about 20, I think, 20 units on 20 double-decker elevators. So a single unit can handle, in this case, two cars that move, they're attached together and move within the same shaft. We also did about 150 units for Columbia University between the inner and outer campus. We did around, I believe it was like 20 for the Radio City Music Hall. We did a few for the Empire State Building, over 80 units, if I remember correctly, for the JFK Airport, and about 40 units for the Rockefeller Center. But there are many more. I think at Trump Tower, we did like 8 elevators there, 2 Wall Street, 14 Wall Street. So those are very well-known buildings. Now, other than the unit, what will you need to install our unit properly? So you will require revised prints where we specify how the unit gets mounted, tested, and wired. So the first and second page of our prints, the revised prints that we prepared, are pretty much standard. The first page shows general information on how the unit gets installed, how the wiring should be performed, and how the validation test should be performed as well. Now, the second page, that's where we specify the configuration. So all our units are universal, and they are manufactured in exactly the same way. So we can mass produce them and turn it around very quickly. But the configuration then is done within the configuration menus of the unit, much like you configure any other elevator controller based on the specifics of the installation. So we have 3 configuration tables. One of them is where we define the specific of the elevator. If the elevator has front and rear doors or only has front doors, that's where we get specified. We have a second configuration table where we specify the inputs, all the parameters related to the inputs. Our inputs can take between 5 volts to 300 volts. Nothing's going to happen if you configure the input incorrectly and you apply a different level of voltage. For example, you can configure one unit for 5 volts and apply 300 volts. Nothing's going to happen. So nothing's going to break. It's just not going to work properly, but it's not going to damage. So this is where we specify that kind of stuff, the type of logic and the voltage for each input. Last, we have the outputs configuration. So the unit has 4 outputs, 2 of which have fixed functionality. Each one implements one of the 2 rules that we spoke at the very beginning. And we have 2 outputs that are spare outputs. And sometimes we need to use them for specific functions. Right now, we're up to like 24 different functions that you can select there, depending on the elevator system that we are working on. Now, on page 3 and above, that's where we specify the actual wiring of the unit. And what we do is we take the original prints, we put it into our own print, and then we specify in red what are the connections. So we have symbols for inputs and symbols for outputs, so that it is easy to identify. Each input has a name and the 2 terminal numbers that they correspond to, and same with the output. So that way the mechanic knows exactly where to go from one of our terminals to the controller terminal. Last, I want to talk a little bit to the tech support. We provide extremely good tech support, and 2 graphs here that I think are very important. The first one on the left is our response time. Most of the calls by far get taken care of within the 15 minutes. So if you call, you may not get to us right away, but we're going to get back to you within 15 minutes, 85% of the time. Now, the second graph that I want to talk about is the call duration. That's very important. So when we get to talk to you, most of the problems by far take less than 10 minutes to resolve. So if you call, pretty much guarantee that, within less than 20 minutes or so, you probably is going to get resolved. Now, with that, I'm going to pass it over to Steve. He's going to be talking about the ordering process and how you get started. Thank you.
Thanks, Omar. So as a distributor for Argus, I'd be remiss if I didn't talk about how you can actually order these products if you wanted them. So the first thing you would do would be to contact Triumph, and you can reach us either at the argus@triumphelect.com website, or you can call our office directly. My team and our team will get you all the information you guys need. We'll answer your questions, and if you move forward, we can provide you with access to the Argus portal. This is where you'll send all of your purchase orders, and you'll be able to track all of your jobs. One caveat I do want to detail is we suggest that as a company, you should really dedicate only one person to manage your jobs and have access to the portal, because the portal really becomes your library of all your jobs, and you can see the statuses and where they're at. So guys, once you have access to that portal, you'll be directed to complete the job survey and upload your drawings, and the portal will track your progress throughout. So from initiation all the way through to completion. And then once the PE stamps your final drawings, you'll coordinate with Triumph for your scheduled delivery. And right now, that entire process from when you first contact us through to delivery is running about 2 to 3 weeks. So it's pretty quick. You can go to the next one, Omar. So I want to give you just a quick view of what the package looks like. You have your units, and then you're going to have your finalized and stamped print, and then you're going to have all the material you need to mount and install that unit. Will all come together. So just to wrap this up, and I want to be brief, Triumph is more than just a distributor for Argus. Our owner has really been supporting and running electrical distribution companies for over 30 years. We have warehouses in Queens and New Jersey. We can offer next day local delivery. We have a walk-up counter, and of course, we can do nationwide shipping. Our inventory and a snapshot, everything that we carry today, from anything traveling cables to matching multis, ropes, all the trough, EMT, greenfield that you might need. We also partner with Smart Rise, so we have a lot of their replacement boards in stock, and we can turn those around really quick. So with that, I want to thank everybody for joining us. I hope you found this informative. Again, don't hesitate to contact Triumph. We'll get you any information that you guys need, any follow-up detail from that we don't cover today in the Q&A session. And I'm going to kick it back to T. Bruce.
Okay, good job. Really interesting, Steve and Omar. It looks like we've got a few questions coming in on the chat, but I've got a couple questions myself that I want to ask. Tell me, how long does it take to install the unit?
So yeah, that's the $1 million question, and the answer, like with all the questions like that, is that it depends. I mean, it depends on a lot of things. So to start, not all of the elevators are the same. Some elevators are very, very straightforward. They have all the signals that need to get monitored right available at the controller. Some that may not be the case for some of them. Depending on how old the elevator, how modern it is, that time may change. Also, it may depend on how accurate was the elevator wired compared to the prints. So something that we see all the time, maybe 30% of the time, is that we get the prints from the company, elevator contractor, but when they get to the job, the controller was not actually wired in the same way that was specified on the prints. So the elevator mechanic will need to do some troubleshooting in that case. Most of the times they just call, we feel, okay, yeah, this doesn't look like it was wired the way it was supposed to, and that needs to get straightened out. So also it depends a lot on how knowledgeable the mechanic is. So I would say that, an adjuster level of mechanic should have no problem. You will be able to figure out pretty much everything on their own. If it is a medium level mechanic, depending on what level of troubleshooting might be required, it might take more time. If it's a mechanic that doesn't know much, they might be able to complete the installation successfully if there are nothing to be troubleshoot about. If there is, that may take some time. In terms of the topology of how the elevator was built, it may take some time depending on whether or not the door locks and the gate switch may need to be separated from the controller, specifically for elevators that are front and rear openings. If there is at least one floor where both doors can be open at the same time, and the door locks and the gate switch are not separated, originally separated, then they will need to be separated and brought into the machine room as two separate set of wires for front and rear components, because the code requires that they are monitored independently. So those are kind of the things that define how quickly a unit can be installed. But I mean, what you guys should do is try one unit. That's what we recommend everybody. Just try one unit with one job that you kind of are familiar with, and that way it will give you a sense of how long things take based on the expertise of the mechanics that you have aside.
All right, very good, very good. Just to remind everybody, this webinar is being recorded. Everyone that's in attendance and who has registered will receive contact information for Triumph and Argus, and as well as a link to the recorded webinar. But let's continue on. We look like we've got a number of people posting questions. So how about this question? Is the unit primarily for older elevator and mod installations?
I mean, it can work for any type of elevator. So that's the short answer. Older and newer elevators. So if the elevator doesn't have the functionality of door monitoring or door lock monitoring, yeah, you just have to install our device. That's definitely a way to do it. So it works with every elevator system that it was manufactured in the US and Canada.
Okay, okay. And further with that question, it looks like they're asking, is there one method to keep the car from running, or does it vary from different types of manufacturer controls that the application is being applied to?
It definitely varies depending on the type of controller. So there are many different, I mean, the end goal is to keep the elevator from moving. And well, that's one of the rules. The second rule is from keeping the doors from closing if certain conditions are met. So the way in which that is accomplished varies significantly depending on the controllers. But that's why we need the prints to analyze the controller and see where the wiring should take place to accomplish that.
Okay. Another question, I'm not sure I understand the question, but it says, is the device to monitor the gate switch, or how is the hall door interlock monitored?
Well, the door locks and the gate switch are monitored the same way. I mean, there are two independent contacts. Most of the time for this type, the type of controllers that will need this addition, they are wired in series. We do have a big advantage there over our competitor, which is that we don't require you to unwire anything from the controller in relation to that. Even though the gate switch and the door locks are wired in series, we are able to monitor both of them independently. So that is something that is unique to our device.
Okay. Yeah, it looks like there's another question asking that similar thing. So that's good. What about Florida? There's a question in here about the new adopted code in Florida. How are you guys prepared to handle that influx of need of this product?
So I mean, in general, I mean, it's the same code that has been adopted all across, I believe, 6 different states other than New York City, and it is the same code. So the same unit will work for all those jurisdictions. So.
Okay. Another question about, having a factory representative or someone from the organization to inspect, test, and certify the final installation. Is that something that you guys have available?
No, that's not something we do. That's something that the first level of validation per se, that's done by the elevator contractor. I mean, I'm talking about how the process played out, at least in New York City. I'm not sure about the details or how things are going to be on different states, but that's something that the authorities on those states will define the process for you. So there's not going to be any question about it. They are going to be defining that. But usually the company install the units, certifies that is working properly. Then the city or the state sends an inspector, or if they authorize a witnessing company, then somebody from that witnessing company will need to go and witness the test to make sure that the elevator now is compliant with the code.
Okay. So tell us a little bit about some of the most challenging situations that elevator contractors might face during an installation process of this product.
All right, so I think like I mentioned earlier, I think the most challenging situation that we have seen with some mechanics is when the elevator has two doors, and there is at least one floor where both doors can open simultaneously, and only two wires go from the shaft to the machine room that has the combination of all the components, all the door locks, front and rear. In those cases, you will need to separate the front from the rear components and bring two set of wires into the machine room. One with a combination of all the front and one with a combination of all the rear components. Now, with our unit, you will still wire that the same way in the controller. It's just that now the series is done at the controller. And we need to have that done at the controller so that we can monitor it. For some mechanics, that may be a challenge, make sure that they are actually separating the door locks and the gate switching in the proper way that we need to. So in our experience, not all mechanics understand that and know exactly what needs to get done. Many do, obviously, but many don't. And your company, we're gonna have to make sure, we recommend that if you know you're gonna be installing one unit for an elevator like that, that you send one of your best mechanics, because it's gonna save you time. I mean, there's not so much, so much we can do on the phone trying to tell somebody to do something if they, don't really understand it. But that's by far, I think, the most challenging when it comes to the installation. Now, from the management point of view, the challenge would be to get us the accurate information that we need to be able to properly prepare the prints. Sometimes the companies don't have the actual prints for an elevator or for a job. Like we said at the beginning, we have done over, I believe, over 4,000 revised prints. So we have an extensive library of prints. So we might be able to find something that is very similar to your situation, in which case it's going to make your life easy. But yeah, we want information that is as accurate as possible.
Okay, and how long does it take to install the unit?
Again, I think that we went over that particular question earlier, and the answer is that it depends a lot. It depends a lot on the type of controller. It depends on how knowledgeable the mechanic is. And it depends on whether or not the elevator was wired to the spec in the same way that the wiring diagram specify. You may be surprised, but I would say that 25% of the time, the elevator was not wired exactly the way the prints show. So somebody would probably need to go there and make sure that it is wired the way it should be. But that's when you calling us for tech support, we will immediately identify those situations and let you know, hey, yeah, this doesn't look like it is. So which one is it? So should we follow the print or the controller itself? But again, it gets resolved very, very quickly at this point.
Okay, very good. So we've got another question here on the chat. It says, it sounds like all the interlocks are monitored as a group. The code specifies only the door lock coupled with the car door. This doesn't suffice the requirement. Can you help?
No, I mean, the code doesn't specify that the code is, what the code says that it is safety functionality to prevent the elevators from working with faulty door contacts or circuits. So for a faulty contact to create a problem or an unsafe situation in the elevator, the circuit associated with that contact will also need to be compromised. And by you monitoring the circuit as a whole, so if you think of it from this point of view, the elevator can only be at one floor at any given time, which means that only one contact is supposed to be open at any given time. So if you see that the whole chain is closed at that point, it means when it's not supposed to, that means that there is a problem there. So again, that is what the code says. So there's no problem monitoring the combination of all of them. The only separation that you may need to do is separation between front and rear components, because they do need to get monitored independently in some situations, especially if you have a floor, at least one floor where both doors can be open independently.
Okay. Okay. There's another question here in regards to providing a written test for procedures. I'm not sure what that's in regards to. Can you answer that?
Can you repeat the question again?
Yeah, it's Kathleen is asking, do you provide a written test for procedures?
Yes, that is part of the first page of the revised print that we have.
Okay.
Just to clarify, I see some more questions about that the code specify that only implying that the door locks need to be monitored independently one by one. So that is virtually, it's not required by code. That's not what the code says. That's the first thing. And also it's virtually impossible. That would imply that any new controller that is manufactured will need to have two wires coming into the machine room per floor. And that's not how the new elevators are built. So new elevators have one set of wires for the bottom, one set of wires for the intermediate floors, and one set of wires for the top floor, because if in case they need to implement access. If what you are saying was true, then an independent set of wire for each individual door lock would be required, which is not the case.
Okay. What about, expediting the prints that are needed?
What about, I'm sorry?
What about when you order this product, how quickly can the prints be expedited?
Depending on the situation, we might be able to expedite at a per company level. A few prints per week. We cannot obviously expedite all of them, but if the company gives us a schedule, hey, we need these prints for this week, we likely will be able to accomplish that. As long as we know which ones you need first, then we can prioritize those.
Okay. And now people wanting to order this product, they will come exclusively to Triumph Electrical as
Yes.
the nationwide representative of this product, correct?
Yeah.
Okay. Okay. So there's got a few more questions here. We got one question talking about the A17.3 does not apply to units installed under A17.1 and later. So he's asking, how does this device come into play?
Well, I mean, if the elevator already complies with the code, because at the time that it was installed, A17.1 already had that requirement in place, then yeah, you will need to do that or not, depending on whether or not it has the functionality. But I mean, every new installation is installed per A17.1. It's just a matter of, okay, what version of the A17.1 was used at the time, and whether or not it's compliant with the door monitoring requirement.
Okay. And then Gary's also asking another question about, does a car door interlock eliminate the need for this device?
No. This is an addition to the elevator. So this is something that monitors the door locks and the gate switch and compares that with other signals of the elevator. And if something doesn't match properly, then it's going to shut down the elevator.
Okay. Okay. Steve, Omar, do you guys see any other questions within the chat or the Q&A that you feel like we should address? Have we covered most of them?
Let's see. I see more questions about the same one that I spoke about. So there seems to be a misunderstanding about every individual door having to be monitored independently. Again, that's not a requirement. Not even new elevators are wired that way. It doesn't really accomplish anything, and it is just it will be a hassle. It will be impractical. Again, even new elevators are not wired that way, so that says it all.
Okay, and you said that in your presentation that this device can easily be installed inside the elevator controller. Most every brand that's on the market, is that correct?
That is true. Yeah, we haven't come across any controller where the unit doesn't fit. I mean, the elevator controller is by far, it's significantly bigger than the unit itself. So you can either mount it perpendicular to the surface of the elevator or on the side walls of the elevator controller.
Perfect. Okay, guys, fantastic presentation. Very informative, very important topic. Really appreciate you guys taking the time to do this. Really appreciate everyone attending today's webinar. Again, information about the Argus door monitoring unit can be found at arguselevator.com. All of this information will be emailed to everyone in attendance, as well as those that were not able to attend, as well as a recording of this webinar, so you can review that at a later time. Steve, Omar, I really appreciate y'all and your time, and I really appreciate everyone attending. Y'all have a great afternoon.
Thanks, everybody.
Thank you, everybody, for your time. Have a nice day.
Take care.